I think everything is working. Hey, welcome everybody to week 9 of Violent Python. We're going to talk about PCAP files this week and kind of walk through last week's solution and do that. So this week's solution similar. This week's challenge is similar, except we're going to actually bring information in from a PCAP file. And I'll talk about a PCAP file in a minute, versus actually capturing traffic from the network live. Okay. So, so again, the agenda for the week is pretty simple. I'm going to go over the review of the week 8 solution, and then talk about PCAP files and talk a little bit more about passive access mapping, asset mapping, and then talk about how we process PCAP files, give you a starter script, and then you guys can start working on some information regarding how to actually turn a PCAP file into something that we can visualize. So with that, let's go ahead and take a look at last week's solution script. And I just ran this just to kind of show you this. You didn't have to do a lot on this week's assignment because I gave you most of it. What I didn't give you was this part here, how we actually take the information that we capture, so I set up things. There's only a couple of tricks here. Number one is you had to be running as admin. Number two, I got a couple of questions that folks were trying to run this script on a Mac or on a Linux machine, Windows only. And just want to make sure that clears. I have another version of this Linux that would work on Mac. I just didn't, I didn't want to confuse everybody. So we were going to be working within the BLE anyway. So I figured you'd be okay. But if anybody really wants the Linux version of this that would run on Mac or a Linux machine, just send me a note and I'll post it for you. It's very similar. It's different in the setup here, but we have to set up the socket a little bit differently on Linux and Windows, and everything else is basically the same. So again, my setup in your starter script was to basically read in a packet and then extract the packet header. And then from that packet header, and I showed you this last week, that we can actually get the protocol number and then convert the protocol number to a name. And that's being done by this mapping function where we've actually created a simple little dictionary that can map the protocol number to a string. So we can have something that we can see instead of 1, 6, or 17, which all we're processing in this area. So the protocol number is the protocol that's running over that particular service, whether it was TCP, UDP, or in this case, ICMP. There's many other protocols, but just in a simple example, those are the ones that we were going to support. So once we actually receive that and convert that protocol number to a protocol name, we basically have everything that we need. But now what we're going to do is we're going to create a capture dictionary, which I created for you, the empty one at least. And as we've done before, and I kind of wanted to show this to you because we've used this kind of dictionary approach to capture and count the unique occurrences of certain elements. Whether it was words, that we were doing, or URLs or email addresses, we use this. But typically in that particular case, what was the unique element, in other words, the key that's related to the dictionary, was typically one thing. So in other words, it was a word or a URL or an email address or something along those lines. So the actual dictionary key was a singular element. Well, in this case, I made the key the source IP, the destination IP, and the protocol. So if the source and destination IPs are the same and the protocol name is the same, then that would make that unique. But you notice something very important. I place those in something in Python called a tuple, not a list. So basically the dictionary entry is one entry still, but it's actually a tuple, which includes the source address, the destination address, and the protocol name, okay? And so if that entry, those 3 elements in that order existed in the dictionary already, we'll get the count, we'll add 1 to the count, and then we'll write that new count back to the dictionary, sort of like what we did for words or URLs or emails, that kind of thing. If it doesn't exist, then we're going to go ahead and create that entry, which again will be the source IP address, the destination IP address, the protocol, and we're going to set it to 1 because it's occurred exactly 1 time, right? And then once we get, so many, I think I put 1,000 or 10,000 in yours, but just so we can do, maybe I'll do a quick demo, knock this down to 10, so that we can show how this works. So let me save that out, and I'll set a breakpoint here. So we can actually, get, a packet. So we got a packet, and I showed you this part last week where we got the packet, and then we get the packet header, and then we can actually use this class that I provided to you, the IP class, in order to be able to extract information to the header using the unpack method within Python. Part of the standard library allows us to unpack information that is packed binary data. So there's, all kinds of capabilities within the IP header, including the TTL, the type of service, the length, the protocol number, the source and destination IP address, that kind of stuff. All of that stuff is packed together within the header of an IP address of a IP packet. So I can actually here, I'm going to step into this and say step into. So it's going to take that buffer that we just got, which is a bunch of packed data, and it's going to get the version number. It's going to get the information that basically is the index, and then it's going to get the type of service and the length. So we can start to look at these. If I want to look at something, I can see length of that packet was that was the ID. This is the offset. This is time to live. That packet that's the protocol number that we're dealing with, in this case with 17. So if you remember back up here, we have a lookup for that. Oh, it's down here at the bottom. That's going to basically say 17 is UDP. And then I can get the source and destination IP address. And those, if you look at source and destination, that again are packed within an IP header, you notice it doesn't look like a source IP address. And that's because it's actually just a double word, within binary. So in order to be able to extract what the actual dotted notation that we're familiar with IP addresses, we have to convert that value into something that's readable. In this case, it's an IP address, 172.27, blah, blah, blah. The same thing with the destination IP address is some other value out on the internet. And so now when we come back into the code that now we've got that object, right? So now I can actually get the name, right, of that protocol number. The protocol was 17, and I can get the name. And now I have the protocol name, which is UDP in this case. And now I'm going to actually see if that entry in the dictionary exists. It doesn't. We know that, right? It's empty dictionary, so there's nothing in there. So that's going to fail and give us an exception. So now what I'm going to do is I'm going to take that combination of the source IP address, the destination IP address, and the protocol name, and I'm going to say that's the key to the dictionary, and I'm going to set its value to 1. Okay. We'll see if we get another packet, which we did. We'll do the same thing here, and we'll see what we got. In this case, we got the same combination of source and destination IP address and protocol name. So now the count initially equaled 1, and now it's actually going to equal 2. So now I can update the dictionary with that new count. So I still only have 1 entry in my dictionary, right? Where did I put that? Capture dictionary only has 1 entry in the dictionary, which has a key of the IP address, source and destination, and the protocol, but it has the value of that dictionary is 2 because we've seen 2 occurrences of that. So we're just kind of keeping track of that. So if I clear the breakpoint here and just say go, we've gotten enough packets to see some things. And all the packets that we saw in that particular case, there were 9 of them, and they all were the same. So that's what we added up. Now, obviously, in your case, you were going to do 10,000. In order to do that, you've got to go out and do some other things, with Google or whatever, and surf the internet. So you're getting a lot more combinations, and you'll see that result. So the only thing you really had to add was basically this section here, And then once you've collected the number of packets that we said that we were looking for, then you're going to create your pretty table, which I did for you. And then you're going to actually take those values from the count, the key, and key 1 and key 2 values. Because remember, key 0 in this particular case. So if I look at the key that I have, the key 0, okay, is going to be the source address. Key 1 is going to be the destination address, and key sub 2 is going to be the protocol, and the count, right, is the value. So that's what we're going to do. We're going to add that row or rows to the dictionary, and then we can print it out and we can sort it in reverse order. So the connections that we're seeing the most often are going to come to the top of the list, which typically means they're ones that we might want to be more interested in. I will obviously post this solution for you so you can play around with it and make some changes to it and that kind of stuff, because you're going to do more of that next week. Any questions on the week 8 solution in the how we handled this with the dictionary? And again, the only trick here was that the dictionary key has to have multiple values, but they have to be part of a tuple in order to be able to make that work. Any questions on that? No, we're good. Anybody?
We're good.
Okay, good, thanks. All right, so let's pop back into this week's briefing, and let's talk a little bit about PCAP files and how they're different than doing this live. So just a quick history of PCAP. It was originally developed and defined by the Network Research Group at Lawrence Berkeley Laboratories. This was a core element of a library in Linux called libcap, which provides low-level packet capture capabilities. Ultimately, this low-level library was developed into the Unix Linux TCP dump utility, which is still used today and extremely useful. It has lots of features, lots of capabilities. So if you're interested in dumping network traffic, take a look at the TCP dump utility and you'll find all of the different switches that are available to that in order to be able to do all kinds of captures of TCP and UDP traffic. Later, libcap was developed into WinPCAP, which was developed for Windows and has similar capabilities to the libcap library. And obviously, we can use that. What makes this interesting is the basic format of a PCAP file is extremely simple, and therefore it's easy to process. And also, it was designed this way so that it could be really fast to write this information out to this file, because, you know, as we were capturing network packets, we had to have a way to basically write them out to disk really quickly. So they wanted to keep the structure and the format of the PCAP file really simple. Other people tried to build other packet capture formats that require a lot more processing. And therefore, now you have to put a lot more load on the application that's going to capture and write that data to disk. That can be done, and there's other formats that people are using today, but PCAP is still very, very popular, especially when you think about things like routers and switches that are doing this, and they're basically hardware-based. They don't have a lot of processing power, lots of memory, that kind of stuff. They're relatively slimmed down. They still use PCAP in order to write this out. And the reason is that PCAP files just have a simple global header, and then they have a packet header and packet data, packet header, packet data, packet header, and so on. They just kind of repeat. So this is kind of what it looks like in a hex dump, where this was what the first, you know, a binary packed data within the packet header looks like. And then we have the second packet, and then the third packet, and there's timing information and a bunch of data that's stored within this particular packet header and the packet data, so we can actually pull that information out. We don't need to look at this because we have utilities that allow us to extract that information and turn it back into the packet format that we're familiar with that we used this week in this week's assignment so we can actually process it. So imagine this device that's out there capturing packets and just putting data in this file in this PCAP format, packet header, packet data, packet header, packet data, and basically putting that in there for us so we can then extract it out later. So other than TCP dump, there are many other utilities that will capture network packets and create PCAP files. They include things like Wireshark, which you're probably familiar with, Kismet, Network Miner, and do some research on your own. You may find some other utilities that you like better in order to be able to produce PCAP file, because there's dozens of them out there that run on every platform. It's not just on Windows or just on Linux, it's other platforms as well. So that was kind of the quick overview. I don't know why this is in here twice. For some reason, my PowerPoint's a little screwed up for some reason. So anyway, back to the concept of active cyber defense. And again, we're focusing on this block here where we're talking about asset identification and network security monitoring is where we're capturing that, that data and basically parsing it. Now, we've been talking about it so far that we've been capturing that live and performing analysis as it happens. But in many cases, what we're doing is actually just generating PCAP files of all of the network traffic in and out of the organization. And they're being stored on large drives. And then if we have an incident or we have breach activity, we can go back and reconstruct what happened on the network from that perspective. And so, again, why asset mapping is vital, all of the things that we talked about last week. So I want to give you an example of an incident where using PCAP files are so important. On April 8th, 2014, the US CERT released the alert TA 14089A or the CVE 2014-160. The Open SSL Heartbleed vulnerability. Virtually no organization, including critical infrastructure stakeholders, could answer the following simple question. Do any of your systems use the Open SSL library? Now, you would think that this would be a relatively simple question to be able to answer, but almost no one could answer that particular question. And there was lots of misinformation put out there. Just a little bit of history about this. This particular vulnerability ended up actually getting inserted into the to the library on December 31st, 2013 at midnight. So it's kind of an interesting, suspicious thing. So, so how does Python fit in to being able to do this? Obviously, it's open source, it's platform independent, it's readable and easily understandable, as we've already learned this semester. Core and third-party libraries provide the underpinnings for development. You saw last week that we're able to use Python in the standard libraries in order to capture packets and analyze them. And the integration of Python with common storage formats like CSV, XML, JSON, SQLite, whatever, allows the immediate sharing of the results of the mapped information that we in fact collect. So again, going back to the active versus passive monitoring, obviously there's pros and cons here, where the pros are active mapping provides immediate results. It's trusted technology. It provides deep results really quickly. The cons is it can be intrusive and can cause system crashes. It only provides a snapshot of the results and can be fooled by sophisticated malware APTs that have compromised the systems so they don't respond to the asset mapping as you would normally expect them to respond. Passive mapping, on the other hand, its pros are it's not intrusive. It provides a broader view of the system and network behaviors because it runs over a longer period of time, and it's more like taking a movie versus taking a photograph. It provides details that can be missed by active mapping. For example, if there are systems that come on temporarily, if there are protocols that are only used at certain times of the day or day of the week, if we did an active map, we're going to miss those. If the system's been compromised, we're going to miss those. The cons for passive mapping, it can be slow. Obviously, it takes days or weeks to basically construct this accurate picture of the environment. And it's certainly more difficult to develop detailed OS characteristics, although it can be done, and it requires a massive amount of traffic in large PCAP files that we're going to talk about this week. So what are some of the key considerations in critical thinking? We want to anticipate intrusions and adapt to them in real time. And this continuous asset behavior mapping is vital to that end in order for us to be able to better understand what's going on within the environment and how we can perform asset mapping in Python. So let's talk a little bit about PCAP processing, however, in Python and how that actually will work. So I have another briefing or two coming up. Let's go back to here, and I'm going to bring up the week 9 starter script to kind of show you how we can actually process PCAP files. So in this case, I'm providing you in the starter script with some lookups. So lookups are commonly used so that when we're trying to translate this very numeric data into something that we can better understand, right? We basically use lookups. So in this case, I'm just saying, hey, we're going to handle 3 different Ethernet types, IPv4, ARP, and IPv6. And then we're putting those into a lookup. So whenever we get the Ethernet type, I can look it up and determine what type it is. This is an interesting one. This is where we can actually translate the MAC address that's part of the Ethernet header that basically identifies the address of the network, the NIC, the network interface card that's in the machine, basically identifies the machine. And we can then do some translations. For example, we can find out who the manufacturer was by looking it up into this database that I'm providing you guys with that allows us to do this lookup and actually get information about the manufacturer of the device. Kind of useful if I'm trying to figure out what it is. Is it a computer system? Is it a network? Is it a car? Is it a refrigerator? Is it a drone? We could tell a lot of that information based on who built it. We could also get information about the transport protocol that was being used, and really important, what ports were used. So I've created a very large lookup table for you so that when we get a port number, we can translate that port number into something that's more human readable. So one of the things there at the top of this particular file is we're using a third-party library here to basically help us process this large PCAP file, for example, and this PCAP library we use to basically extract different layers of the protocol stack in order to be able to get information about those, whether it's at the Ethernet layer, the IP layer, the TCP, or the UDP layer. We can pull that information out of the PCAP file. And that's what the PyPCAP library does for us. So again, the libraries do a lot of the heavy lifting for us. So our simple script here, let me go ahead and set a breakpoint here, and we'll actually run one of these. So this particular script is going to run, and we're going to come down here and we're going to actually ask the user to provide us with a PCAP file they want us to process. The PCAP is a file, like I showed you, the hex dump of that file. I think it's .pcap/. Let me look, because I can't remember the name of the PCAP files that I have set up here. And because my system reset, I have to go find where those are. PCAP, and we do PCAP-test-A. Okay. I'm just giving it the name of the file. I'm giving it a relative path from where my script is running within that directory. It's there. So when I hit enter, it's going to go ahead and open that PCAP file. If it is a PCAP file, it's going to do that. And now we're going to actually use the PCAP library in order to open this. And then we're going to capture that file. And then we're going to start to process that out. So this is where we're going to capture each packet, which is really cool. We're able to iterate through So the core of this particular script is the fact that the captured PCAPs, so as it walks through this file that is PCAP files, I can iterate it through it just like I was iterating through a file. But what I'm getting back is all the details of that particular packet. So think about us iterating through this PCAP file one packet at a time. And when I do that, I'll just go through one of these for you. One of the nice things is the PCAP file in the packet that we're processing. So that first packet, it has a timestamp. So we can actually see what the time structure is of that. You know, the hours, minutes, days, week, day of the week, all of that information is embedded in that PCAP file, okay? Part of that PCAP header for that particular packet, right? And then we can get the Ethernet frame. We can use that to get the MAC address. And that lookup that I mentioned to you, I can actually look up the source MAC, and I can look up that information. And if there was a manufacturer associated with this, I'm not sure there is. Okay, in this case, the manufacturer of that PCAP file that we're looking at for that particular packet, okay, because there's going to be different MAC addresses for each packet depending on the system that was either sending or receiving that data. It happened to be a Raspberry Pi. So they gave us some information, and that's what that lookup does for you in the data set that I've created for you that will do that. So you don't have to do any of that. And then the destination MAC, and then we can look up the destination MAC and see what that one was. That one was something that we didn't know. Oh, that wasn't this manufacturer. And that was VMware. So that was a communication that went from Raspberry Pi to a VM, just to kind of give you some data. And now we can pull information like the frame type. And we can get the timestamp, we can get the source MAC, destination MAC, and we can print these out. And there was that packet that we had, at least the front end of that particular packet. And now, again, you're getting all this. We're going to check the frame type. Was it IPv4? I can look at this. Yeah, it is an IPv4 header. So this is an IPv4 packet. So based on that, I've given you what an IPv4 header looks like. And then you can get information about that IP packet, all of the data in it. We can get things like the time to live for that particular packet. We can get the source and destination IP address from that particular packet. It'll give us those IP addresses. We can get the protocol. You saw us do that live the other day. It was protocol 6 in this particular case. So we can look at transport. Remember, this is all coming from the PCAP file now. I'm not doing anything live on my system at this point. And now I have transport, which is TCP. So now I know that I've got an Ethernet packet. The Ethernet packet was IPv4, and the transport protocol is TCP. So based on that, I can print out some additional information about this one packet. And because we know that the transport was TCP, now I can pull out information that's contained within the TCP header. So this is what the TCP header, this is where we get source and destination port, sequence numbers, acknowledge number, checksums, and a bunch of other information. That's what the TCP header looks like. And we're going to use, again, this package in order to be able to extract the TCP packet. And when we can do that, now I can extract things like the source port and the destination port, and I can print those out. But, and now we go to the next packet. So we processed all of the information we can. So now if I say debug and continue, I probably still have a breakpoint set. No, I don't. So it's going to basically run through this PCAP file, and it's going to print out all of the information that's associated with the PCAP file. So we can get this. So now we're actually iterating through in order, really important. You know, as we're iterating through this particular PCAP file, we're going through it and iterating through it in the orders that the packets were captured. And we're obviously getting the time and date stamp and all of the information that I just walked through in order to be able to understand what happened. That we can use that information in order to be able to determine things after they've happened in order to be able to determine what's happened. So basically, and we can do this all within Python using the PyPCAP library in order to be able to extract all of this information from the PCAP file versus doing it live. Because in many cases, if we want to go in and do it live, we could, but it might be after the fact. So if the organization is capturing PCAP files of all their network traffic, we have something that we can now go mine and basically collect information from that we can use to perform analysis. And again, this is a fairly large PCAP file. I forgot how big it was. It was 11 megabytes in size, a little more than 11 megabytes in size. So there's lots of packets to process, because remember, the data that's stored in the PCAP file is basically packed, and the library is pulling that packet information out, and we're processing it just like we were actually watching the network as it occurred. Any questions up to this point of what we can do in both processing PCAP files that are captured for us, and if you do some research on things like TCP dump, you can see how these PCAP files are created. Any questions? I thought, I have the chat open too. If you'd rather throw a message to the chat instead of yell it out, you're welcome to do that. But this is the kind of information that we can grasp. Is this kind of interesting? Kind of understand what we're trying to do, because different from other tools that may be out there, we may be looking for something very specific here versus something general. Therefore, we could now tailor our Python script to look for specific kinds of traffic, or traffic that's coming and going from specific IP addresses or specific ports, and basically hone that down and look for something specific there that would give us a clue as to what happened, so that we can actually identify the traffic that may have caused whatever problem that we were investigating. Any questions? No questions? This is easy. Nothing, huh? Okay. You guys can still hear me, right? I want to make sure my system didn't do a backflip or something. Okay, so let me stop this script. I think you've seen enough of this. What I want to do is I want to quickly run through. I think one of those PCAP files is a little smaller. Yeah, that one's even bigger, 25 meg. The C is really small. It's only 4K. Let me do the first one again. I'm going to run the solution script, which is basically what you guys are going to work on this week, and taking this a little farther. So again, remember how long this takes. I'm not throwing anything to the screen here until the end. So in this case, if I, while this is running, if I go back to here, go back to our course, we can kind of take a peek at what you guys are going to be doing this week. So in this case, you're going to, I've provided you the PCAP samples. I've provided you a couple of videos as usual. I've even provided you what the sample output you're going to generate should look like for each of the PCAP files that you're going to process. I've provided you with those lookup files that you're going to need. You'll see how those are going into the starter script, how we've loaded those files in. You'll need those to put those in the same directory as your starter script that's there. This is the setup starter script that you're going to be working from. It's the same one that I just ran. And that is a good starting point to make sure that works for you. That'll give you a chance to make sure that all of your lookup files are in the same directory. You can test it out on those PCAP files that I provided you with before you start working on the next part. The next part is to actually take this information and, as we've done before, generate unique connection informations and the number of observations you've had for each one of those. And also, you're going to take the next step, which is you're going to basically look at the observed ports and basically take a look at what those port numbers and the port lookups are, so we can actually see what ports are being used within this. And if this run, okay. So obviously this ran a lot faster because we weren't dumping anything to the screen while we were running. So this is basically just a summary of exactly what you saw in the first script, okay? But just basically putting it in a pretty table. So you notice these first few packets, first few entries, they don't have a source and destination IP address. Why is that? Well, because they were ARP packets, and ARP packets don't contain source and destination IP addresses. They're communicating with each other based on the MAC addresses. And basically, we're looking here, we're seeing where we looked up those source and destination manufacturers, we can see those. And again, in those first few, there's no source and destination port name because the ARP packets don't use ports. They basically communicate at the Ethernet layer. Anyway, if we move down to some of the ones that did have information like source and destination IP and whether they were TCP IP addresses, and basically now we can actually look at the MAC addresses, we can look at the manufacturers of the source and the destination, and then we can actually look at the ports that were being used, and we can translate those ports to what they're used for. So for example, this is a Modbus port that's used in industrial control environments. Rockwell encapsulation, another protocol that's being used for industrial control. So you can start to get a feeling that, hey, wait a minute, this PCAP file that I'm processing is some sort of in some sort of industrial control environment. And then over here, basically, we're determining, remember, we have a timestamp, so we can actually determine what hour this all occurred in. And so you can kind of see how many times not only did it occur, but how many times did it occur in each hour of the day. And we've captured that. More importantly, down here, we've actually captured for each of the IP addresses that we're processing, okay, we can determine what ports were used for that IP address. So you notice that in this IP address, the only port number that was ever used was 137, which is NetBIOS name service. However, in the IP address .30, there were 3 ports that were observed within this PCAP file. This Microsoft Exchange, Rockwell encapsulation, and Modbus were used. In 31, there were also 3. In 32, there were even more, 33. So basically what we're doing in this case is we're saying, okay, for each of the IP addresses I'm observing, I'm going to keep track of what ports were observed for that particular IP address. So we can do this. Now we have kind of a port mapping of what was observed to me. Now you can see where we could take this farther if we wanted to. If I want to know at what time of day or day of week was that particular port utilized, we could have that information as well. It's not required for the assignment, but understand that we have this as our fingertips, so we can take another step if we wanted to, in order to be able to take a deeper look. So this is what you're going to produce. A screenshot like this is provided in the shell, so that you can take a look at those sample outputs that are there, so you kind of can plan what your script is going to do. So again, as we've done before, take this one step at a time, make sure the current setup script works properly and you're getting the proper results, and then start to actually build your pretty table for the information that's coming and counting the number of occurrences of that particular group of values in order to be able to display them. So that's what you're going to be working on this week. This is a little harder than last week. There's a little work to do. You don't have to, you can run this on any computer, obviously. If you're running it within the VLE, the PyPCAP file library is already there for you. If you're going to run this on your own machine, then you'll have to install that special library within your environment. If you go to the starter script, it talks about how to actually do that here.
I have a question about port observations. Are you looking only for the destination port, or IP source port and IP destination port combinations?
Yep, both. So
Okay.
in that particular case, you would be capturing, that's a good question. If you have an observation of a particular IP address and it had a communication that went to or from a particular port, you would log that port, that it used that port. Now, you noticed, it's a good question, a couple things you might have noticed here, some of the ports, and this is done for you because I do this in the lookup I have. You notice that some of them were labeled EPH. And the reason they were labeled EPH is EPH is a shorthand for ephemeral port, meaning this port wasn't a known port like, for example, 502 in the Modbus. It's actually an upper numbered port that's used to basically make a connection. Right, so it's a port that's basically used in order to be able to communicate with another port that is that it wants to communicate with. So in this particular case, the I think this is source port was 502, and the destination port here was ephemeral. So whatever system was communicating with that, the Raspberry Pi obviously, is basically using that ephemeral port. So that's not important. What's important are the ports that we have information about, right? So if they look up ephemeral, you don't have to record those. It's only the ports that actually translate to something meaningful. In other words, they're actually a known, the port that was used was a known port. That makes sense?
Yes, I think so.
Okay. So yeah, so to answer your direct question, yes, you would be logging both source and destination port that was associated with a particular IP address that you're dealing with, and obviously the PCAP library will give you that. It'll tell you what IP address and port were associated, you know, with that result, just like we were doing in the starter script. You know, that all does the same thing. It basically gives you that information that's related to, you know, if it was, you get down to TCP or UDP. So the source and destination port will be here associated with that particular connection. Since you know what the source port is, that would be associated with the source IP address, and the destination port would be associated with the destination IP address. So they would be unique. So you'd have source and destination port that's associated with the associated IP address. So you'll have that information. And there's a lot more information here, but just to keep it simple, this is kind of what we're trying to build this week. We're trying to build this kind of post sniffer that's giving us just a little bit more information. And then next week, I'll show you an application that takes this a lot farther and even will pull information from these IP addresses to determine what country they're in. So we'll do more with this. I'll show you some additional code next week to do that. But just to keep it simple, you're really kind of taking this one step further in getting the port and translating that port. And know that if, you know, in this case, you can kind of see that UDP has source and destination port, but ICMP doesn't, right? So if you see an ICMP packet, it's not going to have a source and destination port. They don't exist. The same thing with ARP. So just keep that in mind, and you can kind of see that from the output that's been generated. I don't know if there was any. Doesn't look like there was any ICMP packets in the in this particular PCAP, but there are ICMP packets in other in the other PCAPs that I'm giving you. But there were ARP packets, and that's why you're not seeing source and destination. And that's why you're not seeing port numbers for those, because they don't have them. They're not used in that particular protocol. Okay, any other final questions? So my suggestion would be to start working on this over the next couple of days. So if you have some specific questions or need specific advice, we can cover those during the Saturday tutoring session, and also on Monday during the office hour. So start to kind of work on this a little at a time, chip away at it. And as you run into issues, make sure you send those to me or Elizabeth. before Saturday and certainly before Monday so that we can give you some, let's call them hints, or, give you some examples how to decode some of this information. Most of it's done for you because the libraries and the lookups are already there for you to basically pull the information. It's about you writing the code that will, kind of organize this data so you can put it into a couple of different pretty tables. Just so it's easier to look at.
I had a question regarding the sample port observations. So when I look at it, I don't see any of the EPH port numbers.
Right.
So are we just, for that, is it just we want to look at ones that actually are mapped to an actual common known port?
That is correct, because the ephemeral ports, are just basically, how do I say this? Just temporal. They're just used, and they have no value except that by grouping them into the category of ephemeral, we just know that they were temporary ports that were used to make the connection. They have no necessary value. So we're only going to basically report information about ports that are known. Short answer.
Okay.
Yes.
Yeah, no, that I understand. Thank you.
Yep. Any other questions? Okay, I'm going to give you 10 minutes of your life back then. I'll post this video, of course, tomorrow. And like I said, I would suggest getting started as soon as you can on this so that you have some time to ask some questions for Saturday or Monday, just in case you run into any roadblocks as you start to chip away at this. Okay. Elizabeth, anything from you that I should, again, thank you for coming to the meeting today, and anything that you've seen that we should mention?
Nothing from me. I think you made a good point though at the end, how the ICMP packets are different than compared to the TCP and UDP like packet headers. So when you are like building your pretty table or gathering all your data, you are going to be missing like the port number or the ports for those protocols.
Correct. And it's a really good point because some people get hung up on that. So remember, I put these definitions of the packets, what they look like here for you, so you know what's possible to extract from those particular transport protocols. So there's not much you can get from ICMP or even from ARP. At least ARP you can get, source and destination MAC. Okay, good points. All right. Well, everybody have a great night, great rest of the week. Be safe, and we'll look forward to seeing you and answering any questions on Saturday and Monday. So have a good rest of the your evening and rest of the week. Take care.
Thanks a lot. Bye for now.